Hi everyone. So now we are ready to learn something called how to measure performance of your model. So basically it's depend upon what kind of the model you have. So might be you trained your model for classification problem, might be you trained your model for a regression model. So it's like a human being actually. So if you are a college student, how I will judge you based on your 12th marks or your undergraduate marks? Okay, so suppose you are a employee of any companies. So how I can analyze how I can understand that how good you are. So for that things I will use some other parameter. So similarly, if we want to understand how good my model is, we have something called performance measurement. And the main reason of taking this uh, or you can understand the main reason of creating this video is just to tell that in what condition we can use accuracy as a performance measurement and in what condition we cannot use accuracy as a performance measurement. So let's start understanding accuracy. So before going to the our actual question, like in the most of the interview they ask that in what situation we cannot use accuracy. So I will come to that solution in 2 or 3 minutes. But before going to that solution, let's understand what is accuracy actually. So it's very simple idea. Suppose you have your data set. Okay, this is your given data set. So as we do in the machine learning, we break our data in some proportion. You can understand 80% of the data we break into the training purpose and 20% of data we break for testing purpose. Okay, so based on this train data, you build your model. Okay, model basically is like you can understand it's a mathematical function. You build a model, and on this model, you will pass your test data. And based on your data, let's call x1, x2, x3. It could be any data. It's the input data, and based on this input data, you will get a output. So basically, output we call in machine learning something called predicted value. Okay. So basically what we are trying to understand in the accuracy, suppose we have 1,000 points. So this suppose we have 1,000 point, this point we are taking in the t-test. Let's say in the testing data. In the testing data we have 1,000 points. So out of this 1,000 point, let's suppose we have 600 positive point and 400 negative point. Okay. So this is data which we have right now in the d-test. So for this 600 data, for this 600 data, my model, my model predicted 540 as a positive. That means what? There is still a 60 point which is misclassified actually. Okay, so let me repeat it again. Out of 600, my model, which I have trained using the training data, on the d-test data, he is just predicting 40 points correctly and 60 point incorrect. And similarly for the negative point, 370, like out of 400, 370 points, he is predicting very well. He is saying that that is a negative and that actual negative. And there are 30 point which is not like it's a misclassified things. So accuracy is very simple idea. That means what? How many number of points you have classified that is correct. Okay, that is the number of correctly classified point divided by the total number of points in your test data actually. So here you can understand we have 90 point which is a error actually. Okay, and how many points we have classified correctly? This thing, that's a 9110. So out of 1,000 points, 9110, sorry, 910, that is a, this is your accuracy actually. That is what? 91%. So you can understand that 91% of the time your model is predicting a true result actually. Like there is a still 9% of the error. That is not a problem. So this is a just a definition you can understand of what is accuracy. Now it's time to understand when we cannot use accuracy. See, first of things you can understand, uh, as I told you earlier, that your model could be the classification problem, or you have created a model for the classification problem, might be like you have also created a model for regression also. So accuracy we are using for classification problem here. Okay, so now let's come to the situation where we cannot use accuracy to understand the performance of our model actually. So let's come to the that point. So here you can see, suppose we have a test data. So this is something input. Okay, so this is something real one, which we know that. Okay, like for this input we have class level one, class level one, class number zero, class number zero. So suppose I build. Suppose we have D train data. So based on this data, I created two different model. Let's call model one and let's call model two. Okay, so now this is model which I have created using my D train. Now, suppose I am going to give the query point. Let's call XQ. Suppose I am giving the query point to this model. Okay, and similarly, I am giving this query point to this model. Both are two different model. Suppose this model is not giving you class level as a output. This model will give you probability score actually. Suppose 0.5, 0.6, like that. Okay, so I'm just clearing the picture. Suppose my machine one, that is a model one, on this input giving the this output. That is a he's returning the probability score actually. Okay. So based on, so this is my machine one. That is a basically you can understand machine, or you can call it model. So this is model one. On the model one, for this input I am getting 80%. Okay, that is the probability 0.8. Similarly for 0.5. Similarly for this, so you can understand. So I'm getting this thing. So this thing you got the point how I filled this data. Okay, so this is my predicted probability by via this machine via this machine. Okay, so if you see it, both are different actually. Now suppose we want to understand accuracy of the system. Okay, how accurate my model actually. So for those things what I'm doing, suppose this is, suppose I know that if probability is more than 0.5 or equal to 0.5, we have to replace, we have to predict our class level as a 1, otherwise I will 0. So see, it is a greater than 0.5, so I have predicted class 1. It is greater than 0.5, I have predicted class 1. Similarly for this one, because this is less than 0.5, I predicted 0 and something like that. This is 0.48. Okay, so if you see it, this probability score completely different from each other actually. That means what, this model are completely different. Otherwise you can also say that model M1 is far better than M2 by looking this data actually. But if you see the class level things, it feels that both model are same. Like this is a class level produced by the model 1 and this is a class level produced by the model 2. So by looking this two predicted value, it seems that both are same. That is not true actually. So what we can conclude from this understanding, we can conclude that accuracy is not good performance measure when our model is returning something called probability value. So if your model is returning some probability value, don't use accuracy to check your performance of your model actually. So that is a key point actually. So same things I have written here also. You can read it. Okay. So that is not a complex part. I hope you understood my point. So you can observe that predicted class level actually for M1 and M2 is same. So in this case, it seems like that both model are same. But actually this is not true, because this my model M1 and M2, they are not returning the class level actually. They are returning some probability value. So accuracy concept, like to understand the how good our model is, we cannot use accuracy on the probability score actually. So that is one observation, and conclusion is what, we cannot use accuracy when our model is giving something, or you can say when model is returning something, a probability score actually. So hope you understood the point. So in upcoming future, we are going to understand confusion matrix and the remaining performance measurement for a model. Hope you liked it. Thank you so much.